let's continue with HCN and BCl3. HCN, that is hydrogen, carbon, and nitrogen. The electron dot structure for this is this one. And for the shape of HCN, that is actually linear. So here for hydrogen, the electronegativity, this one is 2.1. Then for carbon, that is 2.5. And then for nitrogen, that is 3.0. It's composed of two bonds. We have the bond between hydrogen and carbon. Let's focus here first. The difference here is 0.4. That's 2.5 minus 2.1. The difference is 0.4. Now, this can be considered as a nonpolar bond. Again, from 0 to 0.4, that's nonpolar. But some considers this one as slightly polar, and for the sake of making diagrams here, we will consider this bond as slightly polar. So we're going to add some vectors and arrows on this diagram. Again, carbon 2.5, hydrogen 2.1. This is much more electronegative, so in effect, this electrons will move closer towards carbon, giving it a partial negative charge, and this one partial positive charge. Then here we have another bond, nitrogen and carbon, 3.0, 2.5. This one is a polar bond also. So nitrogen is much more electronegative compared to carbon, so these electrons will move closer towards nitrogen, giving it a partial negative charge, and this one is partially positive. Now, what's the overall charge for this molecule? Again, it's composed of two polar bonds, pero again, the shape and the vectors will determine the overall polarity of the molecule. Let's add these vectors. Let's start from the first vector, then the second vector will start from the head of the first one, then we add this one. So that's the beginning, then this one is the end. So this one is the overall polarity of this one. This is the resultant vector. This one is polar, obviously, because here this one is partially negative and this one is partially positive. So HCN is a polar molecule. So here the charges will not be cancelled. So let's go to BCl3. This one is boron. Then we have tatlong Cl. This is the electron dot structure. Now let's proceed to its actual Vesper shape. That's boron. Then here we have Cl. Right. We have here Cl, and we have here Cl over here. Now let's write the electronegativity here for Cl, that is 3.0, 3.0, 3.0, then 3.0. Then for boron, that is 2.0. If we go here 3.0, 2.0, this is not equal sharing, right? This is much more electronegative compared to the boron, so these electrons will move closer towards chlorine, giving it a partial negative charge. This one becomes partially positive. The same thing here, 2.0, 3.0. The electrons will move closer to Cl. This becomes partially negative. This becomes partially positive. The same thing here, 3.0, 2.0, partially negative, Cl. This becomes partially positive. Now here we have three vectors, so how do we add these vectors? So we can use okay, let's simplify these vectors first. So this is something like this, right? We have this one, this vector over here, then another vector over here. So first is we first add these two vectors, and then for this one is we can use the parallelogram method. So we can draw here a parallelogram. Then the resultant vector for these two vectors will be this one over here. Now again, this one is the same pattern. Now again, we added these two vectors to form this vector over here. Now again, we have two vectors over here. How do we add this? Let's start with this one. Then let's add this one over here. We start from the head, padulong sa tail, and as you see, this goes back, right? So this cancels. So these vectors cancel each other. So overall, these charges will also be cancelled over here. So overall, BCl3 is a non-polar molecule. Again, so this shape, by the way, so this trigonal pyramidal, by the way, this one is symmetrical. And pag symmetrical yung shape, symmetrical, here the charges will be cancelled. and this will be a non-polar molecule, non-polar. Let's go back to this one. So these are the different shapes. Pag linear, this is symmetrical. So this one will be non-polar. This is also non-polar, 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 and non-polar. Bent, so there's a space here, right? So it's not actually. So it will give this shape a polar. So this will be a polar molecule. This one is also a polar molecule. This one polar also. This one polar, then polar. This is linear, the same thing for this one. So this will be a non-polar. This is square pyramid. This one will be a polar molecule. Square planar, this one will be non-polar. T-shape. T-shape, this one is polar. Then here's a linear, again, linear, this one is a non-polar. So lahat ng naka-check dito, all of this will be non-polar. Then the rest will be polar. Yung uh, so again, yung polarity, it depends on the shape of the molecule, and to identify the polarity first, you must first identify the shape of the molecule. And again, the shape of the molecule is part of our discussion in the VSEPR theory. Let's proceed to the last set of examples. We have NH3 over here. Okay, NH3, we have nitrogen, hydrogen, then hydrogen, and hydrogen. We have here a lone pair. Okay, a lone pair over here. So the actual shape for NH3 is actually like this one. H, then we have this one, H, then we have this broken line over here, H, then we have lone pairs above. So now let's put the numbers here. For nitrogen, that is 3.0. For hydrogen, that's 2.1, 2.1, then 2.1. Let's start here first, 3.0, then 2.1. It's not equal, right? So here the electrons will move closer to the nitrogen because that's 3.0 compared to the 2.1. So arrow padulong sa nitrogen, this becomes partially negative. This one becomes partially positive. The same thing for this one. Partially positive, then partially negative. The same thing for this, partially negative, then partially positive. So again, this one is discussed kanina. The shape for this is trigonal pyramidal, and again, the shape for this is this will be a polar molecule. So here, the charges will not be cancelled, and actually here yung overall polarity, di ba? As we see here, ang pattern kay pataas. So the overall polarity here is this one, pasaka. So this one is partially negative, yung taas. Then ang ubos, that one is partially positive. So again, NH3 is a polar molecule. Then for CH4, let's keep the electron dot structure. The shape for CH4 is that's tetrahedral, right? Hydrogen, hydrogen over here, hydrogen, then wedge hydrogen. Then again for carbon, that is 2.5. Then for hydrogen, 2.1, 2.1, then 2.1. Again here the difference is 0.4, but still some considers this one as slightly polar, so we're going to use the vectors here. So here 2.5, 2.1 padulong sa carbon, partially negative, partially positive here. The same thing here, partially positive, partially negative, partially negative, partially positive, sorry, partially positive, partially negative. The same thing here, partially negative. This one is partially positive. Now, this one again, this one is symmetrical. Then pag symmetrical, this charges will be cancelled. So overall, this will be a non-polar molecule.